Hydraulics and pneumatics are both kinds of fluid power. Hydraulics is a system that uses liquid. Pneumatics is a system that uses gas. In hydraulics, that liquid is usually oil. You do see some weird systems with other kinds of materials, but usually it's oil. Pneumatics uses air. In a hydraulic system, we reuse that oil. So we've looked at how the oil gets returned to the tank, and then the pump pumps the oil back out of the tank and out to the system again. In pneumatics, the air is exhausted. That is, it's released. Once you use the air once, you just release it into the air and that's it. The thing about liquid, like oil, is that it's incompressible. You can't compress it. While air is compressible. With oil, having this fluid that is not compressible, you can control it with precision. With pneumatics, using air, because air is compressible, it's kind of like working with a spring, it's less precise. Hydraulics is slow, or slower than pneumatics. Pneumatics is fast. So if you have situations where you don't need a real high pressure, but you need things to move fast, you might use pneumatics. And you see all kinds of manufacturing shops where there are air systems throughout the shop operating all kinds of grabbers and cylinders and so forth. The basic idea, the difference, is that when you're transmitting force through a liquid like oil, it's like you're using a solid because it's not compressible. Whereas when you're transmitting force through a gas, it's like using a spring. So that's why pneumatics is less precise than hydraulics. Also fast. Pneumatic systems use a lower pressure than hydraulic systems. So think about what you know about the relationship between force and area and pressure, PSI. If you have a lower PSI in your pneumatic system, that means the cylinders have to be bigger for the same load that you're lifting or moving. Also, pneumatic systems need various kinds of air conditioning. We need to remove moisture from the air, and we need lubrication, oil droplets, oil mist that's squirted into the air. We don't have that in hydraulics. So in a pneumatic system, the fluid is just air that is all around us. It's free. And you don't have to reuse it, you just use it once and exhaust it. Thinking about air that surrounds our planet. Like anything, air is heavier the deeper it gets. So when you are up at the surface of the atmosphere, you're at the end of the atmosphere, no more air. Up there, think about a 1-inch square column. It doesn't weigh anything. There's nothing above it. As you start to go down that 1-inch square column, there's more and more air sitting on top until you get down to sea level. And at sea level, that 1-inch square column of air happens to weigh 14.7 pounds. Think about what you know about pounds per square inch, or PSI. At the bottom of that 1-inch square column, that thing that weighs 14.7 pounds is, in other words, 14.7 pounds per square inch, 14.7 psi. That is atmospheric pressure. And it's nothing more than just how much a column of air weighs that goes all the way from the surface up to the end of the atmosphere. And notice this slide is using the term psi-A, psi absolute. And the reason for that is that when we put gauges on systems, we don't really need to know that atmospheric pressure is 14.7. Thank you very much. We know that, and that's what it is all around us, unless we're at a high altitude. So what we really want to know is how high is the pressure above atmospheric pressure. And so our gauges start with their 0 point at atmospheric pressure. When you look at a gauge, a pressure gauge, and it says 0, that actually means the atmospheric pressure of 14.7. That if you're including atmospheric pressure in something, you call that absolute pressure. If you have a gauge that just starts at 14.7 as the 0 point and goes from there, that's called gauge pressure. And so we write those psi-A for absolute and psi-G for gauge pressure. And gauge pressure is what we use in all our fluid power systems. So when you look at a gauge on a system, it is telling you how high is this system above atmospheric pressure. And then just in the interest of thoroughness, so the gauge pressure starts with its 0 point at atmospheric pressure. You can also have a vacuum. There are gauges that read how far below atmospheric pressure we are, which means you have a partial vacuum. And we won't talk about that here. I think I do mention that in the optional slides that are after this one, if you want to look at gas laws and inches of mercury and vacuum. But what we really want to know is gauge pressure starts at atmospheric pressure.